The Earth System, a video series for educational institutions for free use presented by the German Geological Society, the DGGV. Hello everyone, I welcome the viewers of another episode of my video series on the Earth System. As with all other videos, I would like to point out the opportunity, giving me feedback if you have any questions or comments. You will find my email address on the first page of this video or on the website. In this video, I would like to explain the consequence of the gradual increase in thickness of the lithospheric mantle as it drifts away from the spreading center. This is in contrast to the oceanic crust, which is formed with its final thickness at the spreading center. The increase in thickness of the lithospheric mantle is responsible for the fact that the lithosphere, and now I'm talking about the package of both oceanic crust and lithospheric mantle, becomes heavier with increasing age and gradually sinks as it drifts away from the spreading center. Let's have a look at this using the Atlantic as example. This is a bathymetric map of the central Atlantic. Bathymetric means it shows the topography of the seafloor with all submarine ridges and mountains, the seamounts. This map shows the so-called predicted seafloor topography. That means it is not a map of the directly observed morphology, but rather a seafloor topography calculated based on satellite measurement data. The resolution is only very rough, but despite this, it is very suitable for kilometer-sized structures. And we want to look at these across the entire width of the Atlantic. If we look at the elevation profile along this line, which crosses the entire Atlantic, we can see that there are deep abyssal plains on both sides of the mid-Atlantic ridge. The difference in height between the ridge and the abyssal plains level is at least 2,500 meters. In other words, the ridge is a submarine mountain range, 2,500 meters in height. This difference goes along with the increasing age of the oceanic lithosphere. And this is a consequence of the gradual thickening of the lithospheric mantle, which makes the lithosphere heavier with increasing distance to the spreading center. This figure shows the age of rock samples taken from the oceanic crust at different distances to the spreading center and at different depths. And there is a clear correlation between age and depth. At around 80 million years ago, you can see a clear flattening of the curve, which shows that, as explained in the previous video, there is no longer much lithospheric mantle growing from below. But how can oceanic lithosphere become heavier with age? This is not entirely obvious at first. The important behind this is that we look at the average density of the oceanic lithosphere. It is not just the lithospheric mantle or the oceanic crust. At the very beginning, at the spreading center, there is only the oceanic crust at the top. Directly beneath is the asthenosphere. Therefore, the density of the newly formed crust at this point, still without lithospheric mantle underneath, is 3.0 gram per cubic centimeter. As the thickness of the lithospheric mantle increases with distance to the spreading center, the average density of the lithosphere, which includes the solid outer shell of the Earth, increases. It is then 3.15, 3.2, 3.25, and finally here about at the end here about 3.3 gram per cubic centimeter. And caused by the isostatic compensation, I already discussed this in a previous video, the lithosphere sinks deeper into the asthenosphere, which is why the deep abyssal plains formed. At a certain time, an interesting effect comes into play. When the oceanic lithosphere is quite old, let's say older than 120 to 150 million years, it may become heavier than the asthenosphere underneath. The difference is not that big. 3.3 gram per cubic centimeters for the lithosphere versus 3.25 gram per cubic centimeter for the asthenosphere. But if heavier material lies above lighter material, we have a density inversion and thus an unstable layering. And this can ultimately lead to the development of a new subduction zone. It must not happen, but it can. Such a process is called spontaneous subduction. So that's it for the topic of structure and aging, or becoming heavier, of the oceanic lithosphere. In the next video, I will go into more detail about the formation of new oceanic crust in a spreading zone. This time, thank you for listening, and I'll be happy if you stick around. And I recommend continuing with a video on the formation and structure of oceanic crust.